Hello everyone, this is Ms. Piekarski and I am doing the Algebra 1 final test review. And let me go ahead and get started. So the first one, the question has us solving the compound inequality and then graphing it on a number line. So we have two parts of this inequality. We have negative r plus 9 is less than or equal to 2, or 2 times r plus 3 is less than 7. Okay, so the first thing we want to do is we want to get our variable r by itself and everything else on the other side of the inequality. So, we have two parts to this. So we're going to treat them as two separate things, and then we're just going to graph them both on the same line. All right, so the first thing we want to do is we want to get rid of this plus 9. So we're going to subtract both sides by 9 over here. And when we do that, we end up with negative r is less than or equal to negative 7, because 2 minus 9 is negative 7. But then we need to go ahead and get rid of this negative. And so we're going to divide by a negative 1. And so we're going to divide both the negative r and the negative 7 by negative 1. And when we do that, we get a positive r on this side of the inequality, and we get a positive 7 on the other side of the inequality. The biggest rule to remember about dividing or multiplying by negatives is when it comes to inequalities, anytime you multiply or divide by a negative number, you have to flip the sign. So up here it was less than or equal to, but now because we divided by a negative, it's going to be greater than or equal to 7. Okay, now on this side, again, we have to isolate the r. So the first thing we're going to do is subtract 3 from both sides of the inequality. And when we do that, we're left with 2r is less than 4, because 7 minus 3 is 4. And then we're going to divide both sides by 2. And when we do that, 2r becomes r, and 4 divided by 2 becomes 2. And because we were dividing by a positive number, we're going to leave the inequality exactly the way it is. All right. So we have two parts of this inequality. We have the statement that r is greater than or equal to 7. And we also have the statement that r is less than 2. So for the greater than or equal to 7, it will be this side. And we're going to put our little dot at 7. So if these tick marks, each tick mark is 1 unit. And then, so this is 6 and this is 8, so 7's right in the middle. And this dot is filled in because of the equals line here. And because r is greater than or equal to 7, we're going to draw our line or point our line to the right. Now this part, r is less than 2. Instead of having a filled in circle, we're going to have just an open circle. And it's going to be pointing to the left because r has to be less than 2. So this is how we would graph our inequality of r is greater than or equal to 7 or r is less than 2. The next problem, we are graphing the solution for this system of equations. And the easiest way to do this is to show you how to graph it on a calculator. And so let me pull up my calculator really quickly. Whoops. We're going to pretend I didn't do that. So here's my calculator. And I know I might have some people watching this video that don't have access to the Inspire calculators, but hopefully my students will have access to it. You can graph inequalities on a regular TI-84 graphing calculator as well. It's just slightly different steps. All right, so for the Inspire, you're going to go to your graphing screen, and if you don't have a line up here to type in your formula, you just push the tab bar. And we want to graph inequalities, not functions. So the first inequality we're going to graph is y is greater than negative x minus 2. So the easiest thing to do here is delete the equals sign, and that will pull up all of these options here. And we want y is greater than, so we're going to go to option 4, y is greater than. And then we're just going to go ahead and fill in the rest. So negative x, and then minus 2. Make sure you're using the minus sign and not the negative sign for the minus 2, because those are two different things. Once you have that typed in, you push enter, and then you get this graph. Now to type in the next part, go ahead and push tab, and you'll notice that you don't have the inequality options anymore. You can go ahead and type it in as well. You do Y, and to get this less than or equal to symbol, you're going to do Control and then the equal button, and that pulls up all of your inequalities, and that's just Control and equals. And we want the less than or equal to symbol, then 3x plus 6. Okay, and we're going to go ahead and push enter there. One thing to note is that there's a slight difference on these lines. So this line is dotted or dashed, and this line over here is a solid line. Okay, so if this is a multiple choice test, you might have 4 different graphs, and one of the graphs, and most of the graphs will look very similar to this, but sometimes this will be the solid line and this will be the dotted line. So not only does it need to look the same, but whether the line is dotted or solid also needs to be the same as well. So for this one, this is what our graph would look like. And for the most part, when you open up your graphing screen, it gives you the standardized graphing window of -10 to +10 for your x values, and -6.67 and +6.67 for the y values. However, your graphs on the graphs that will be on your paper, hold on. Let me do -8. I don't want to see that. Okay, so the graphs that will be on your paper, let me see if I can get these to show up. Why are they not showing up? Come on. Sorry, guys. I don't want to see that one. I want to see that. Dang it. It's not going to show up for me. There we go. And that one. There we go. On your test, first of all, you're not going to see these equations. I'm not going to have it labeled for you. But on your test, what you might see is, notice how I'm making these lines a little bit darker. So your test will have darker lines or bolder lines here and here than what you would typically see on your calculator. You just need to hover over those lines with your mouse pad and kind of point at them, and it will show whether it's dotted or solid lines. All right, so this is what we got on our calculator. All right, so let's go ahead and move on to the next one. Graph the solution for this inequality. Now notice here we had in this equation, when we graphed it on a normal graphing screen, we had a y variable and an x variable as part of our inequality. But when it's just a situation like this, where you just have one variable, then you're going to graph it on a number line like this. Okay, so to graph the solution for this equation, -2 times 3x plus 2 is greater than 8. First thing we want to do is probably just, so there's 2 options here. You can either distribute this -2 throughout the whole thing, or you can just divide both sides by -2. If you have a even number here, then it's easier just to divide both sides by -2. And when you do that, on the left side, you get 3x plus 2. Whatever's left in the parentheses here is what you have on the left side. And then 8 divided by -2 is -4. And also notice that the greater than symbol became a less than symbol because we were dividing by a -2. Okay, and then the next thing we want to do is go ahead and subtract 2 from both sides. And when we do that, we're left with a 3x on the left is less than -6. And watch this carefully, because remember when we do 8 divided by -2, we get a -4, but then when we're subtracting by -2, it's negative, or sorry, when we're adding -2 or subtracting by 2, whichever way you want to say it, we have a -4 minus 2, and that gives us a -6 because they have the same signs here, but they're both negative. We're just going to add them, and we get a -6 here. Now the next step, we want to get rid of the 3 here, so we're going to divide both sides by 3, and we're left with x is less than -2. Notice when we divided by the +3, we did not switch the signs again. So this equation just says that x is less than -2, and so our inequality, we have this little open circle at -2 because we don't have the equals line here. And then x is less than -2, so the x has to be somewhere down here. All right, next problems. We need to multiply two binomials together, and there's two ways we can do this. We can either FOIL it or we can box it, and I'm going to show you both ways. So to FOIL, you have to multiply the first terms, the 9 times d and 9 times d. And then we're going to add the first term multiplied by the last term, or the two outside terms. That's the O part of FOILing. So the 9d times -7. And then we're going to multiply the two inside terms, 7 times 9d. And notice that I'm adding each pairs of number of terms that I'm multiplying together. And then I'm going to multiply 7, the two last terms, so 7 times -7 is going to be at the very end. And then go ahead and with this, you would multiply 9 times 9, that gives you 81, and d times d is d squared. And then 9d, and that's a positive 9d, times -7 will give you -63d. And then positive 7 times 9d gives you positive 63d. And then 7 times -7 gives you a -49. Notice the two middle terms are opposites of each other, so we have a -63d and a +63d, so those cancel each other out, and we're left with 81d squared minus 49. You can box this instead of FOILing. You just set up your, doesn't matter which terms you put where. You can put the first binomial up top and the second binomial on the side, or vice versa. I think I did the first binomial I put on the side and the second one I put on the top. It really does not matter where you put those as long as you have one on one side and one on the other side. Okay. So now with the box method, for those of you that don't remember, you're just multiplying for each of these boxes. You're multiplying the column and the row. So you'd have 9d times 9d, which is 81d squared. And over here you'd have -7 times 9d, which gives you -63d. Down here, 9d times 7 is positive 63d. And right here you have -7 times +7, which is a -49. And then you, one thing to remember is that you can do these little diagonal lines, and it kind of separates the like terms. So 81d squared is on its own. And then these two middle terms, you would combine those, they will cancel each other out. And then we're left with -49 at the end. And notice that we get the same answer whether we FOIL or do the box method. All right, next one. This is a word problem. We have Dave, Erica, and Tim are buying supplies for a picnic. If they discover that 2 liters of soda costs $1.69, how much would 4 liters cost at the same rate? All right, so the biggest thing is to figure out what you're going to multiply this $1.69 by some number, and we've got to figure out what we're multiplying it by. So the difference of 2 liters, so we start I can get 2 liters for $1.69. So 4 liters is twice as much as 2 liters. Your word problem on your test, it might say, how much would 6 liters cost at the same rate? So if I wanted to buy 6 liters, 2 times 3 will give me 6 liters, but 2 times 2 gives me 4 liters. So in this case, we're multiplying the cost, the $1.69 times 2, because 2 times 2 equals 4. Okay, and so I do 169 times 2, I multiply those two together, and I got $3.38. Solve the linear system. We've got two equations, and I want to know when are those going to intersect in a graph. So I'm going to graph these, and I can go ahead. Whoops, that's not what I want to do. Sorry. I can graph them on my calculator. Let's go to the next set of problems. Let me make sure I can see everything that I want to see. All right, there we go. Now I can see the equations. All right, so with this one, if you have the Inspire calculators, you can just graph these equations exactly the way you see them. Again, pull up a graphing screen, push the tab bar, and notice we have both the x and the y variable on the same side of the equation. So I'm just going to graph this as a relation by deleting the equal line. I go to relation, and then I'm going to just type in the formula exactly the way I see it. So 3x plus 8y is equal to, and notice I'm using the equal button here, not the enter button down here. Negative 22, make sure you use the negative sign there, and then you just push enter, and that's what your graph looks like. Now I'm going to graph the next one, so I'll have to push tab to pull up my formula bar again. 5x minus 4y equals 30. Push enter, and let me move my graph up so we can see it. So here's the blue line, here's the red line, and I want to know when are those intersecting, okay? So the easiest thing to do, go to menu, analyze your graph, find your intersection, okay? Lower bound and upper bound, they want you to put that intersecting point in between these two dotted line, this dotted line that you see here. So lower bound just means I need to be on the left side. Upper bound means I need to be on the right side. And for these two equations, they will intersect, or they will equal each other when x is 2.9 and when y is negative 3.8. Okay. Now, you can do something similar with the TI-84s, except with the 84s, you have to go ahead and put the equation in slope-intercept form. You cannot just leave it in the standard form here. Okay, so you would want to move this 3x to the left, and then you would divide by 8, and so you would have negative 3x over here. Whoops, and you would get rid of this 3x here, and then you would divide by everything on the left side by 8, so you would have negative 3x divided by 8 and negative 22 divided by 8, and you would set up the equation like that, or you would enter the equation in your calculator like this. Now for here, it would be easier to move the 4y over and subtract 30 from both sides. So we're going to go ahead and do that really quickly. So it looks like this. Then to get rid of the 4, we're going to divide everything by 4. And 5 divided by 4, and you would just plug it into the calculator just like that, like you see this. And we end up, and then you can analyze your graph and find the intersecting point. You can do the analyzing the graph thing with both the 84s and the Inspires, okay? And that's how we get the answer. The x is 2.9 and the y is negative 3.8. Be careful when you're doing this because it is going to be a multiple choice test. You might have an answer option where it says has a negative 3.8 first and then the 2.9 over here. These are not interchangeable. This is your x value, this is your y value. On to the next set of problems. With this one, we've got several different systems of equations, and the question is how many solutions do each of the following linear systems have? The best thing to do would be to graph these, and I've graphed all 4 of the problems already, so I'm just going to first show you what the graphs look like, and then we'll talk about how many different solutions they have here. All right, so the first one, notice we have 2 parallel lines, and with those you have no solutions. There's no spot where these 2 lines will intersect. Okay, when you're looking for solutions to linear systems, you're graphing it, you're looking for where those 2 lines will intersect. And parallel lines don't intersect, so there's no solution. Here, these 2 lines intersect right here at, looks like -4, and so there is one solution here. And then the next problem, they're intersecting again one time, and that is approximately right there. I'm not sure exactly where it is, but I see one intersection. Now, for problem part D, this one might be a little bit confusing because a lot of you on your graph, you won't have the 2 different colors showing up. And the reason why I have 2 different colors here is to indicate that there's actually 2 lines there. Because when you graph these 2 lines and they're just one on top of the other, the first line gets covered up by the second line. So if you're not really paying attention, you might not realize that. So let me go ahead and show you what it looks like when you're graphing this. And again, let me move this down, move this up. So let's go ahead and graph this. Again, delete the 0 or the equal button so you can just plug it in exactly the way you see it. 5y equals 20. Okay, so notice that this line is blue, and there's my equation. Now to graph the next one, I have 3x plus y equals 4. And notice the blue line, it looks like it just disappears. Well, it really doesn't disappear. What happens to it is it gets covered up by this red line. So now that I've changed that red line to be dotted, then you can see it in the background. You can see it there. Okay. So that's why those lines are just right on top of each other. Okay, so that's why on this picture I changed it so that you see the red dashes and then right below it you see the black line. So the results are, though, for these 2 is because they're one on top of each other, is that there is infinitely many solutions. So from negative infinity to positive infinity, every single one of those numbers will be a solution to this system of equations. All right, next is what is the solution for the linear system. Okay, so this is slightly different. We only have one solution, but we need to know where it's at. So with this one, again, you're going to graph it. And so when you graph it, it looks like it's right here. And you can just count the tick marks. Notice on my thing or on my picture, I have grid lines. You may not have grid lines on your graphing screen, but you can turn those grid lines on. Let me show you really quickly how to turn these grid lines on and off. So they're on right now. If I go to Menu and View, Grid, and now the grid, there's no grid. Okay, so if I want to see those lines, go to Menu, View, Grid, and then Line Grid. Okay. So with this problem, we can just count the tick marks. So your x value, you're going -1, -2, -3, -4, and then the y value you're going down to, so -1, -2. So your intercept is at -4, -2. Okay, what are the solutions to the following equations? Here we have quadratic formulas. And we need to go ahead and factor those so that we can find our equations. And when we are factoring this, we want our number here in front of this h is a 1. Remember, if there's not a coefficient or a number in front of your variable, then the number is 1. So I'm going to have to factor this by grouping. So I need a number or two numbers that will add together to get 1 or positive 1, and that will multiply together to get -56. Okay, now there's lots of possible options. 1 times 56, 2 times 28, 3 won't factor in, 4 times something, I think. Let me see, yeah. So 4 times 14. So there's lots of different options here, but we want the option that will give us a positive 1 when I add the two numbers together. And one thing hopefully you notice is that I have a negative sign in front of this number that we're multiplying. So that means that one of my variables needs, or one of my terms needs to be negative. And because this is a positive, then my bigger term would have to be positive. So here, I need two numbers, two digits that are sequential, so that I can get a positive 1. And so -7 times 8 will give me -56, and -7 plus 8 will give me a positive 1. So I'm going to use the factors of -7 and positive 8. And so I'm going to go ahead and group those. So remember, when you're doing the 4 terms, this is just your first term. This is your last term, just goes down. But then your factors, so the -7h and then the plus 8h, and that gives you a positive 1h. Go here. Then we're going to factor by grouping. So the first two terms, you can pull an h from both of those terms. Okay, and so we pull out an h and we get h minus 7 in parentheses. And then the second two terms, it looks like we can only pull out an 8, and we're left with h minus 7 in parentheses. So now both of these terms have the x minus 8, or sorry, h minus 7. So we can factor that out, and what we have left is the h and then the plus 8 over here. So those are our two factors. Now that we've factored this polynomial, we want to set both of those factors equal to 0 and solve for h. So we'll have h minus 7 is equal to 0, and h plus 8 is equal to 0. Then we're going to solve for our h value. So I have to add 7 to both sides, and that gives me h is equal to 7. And then over here I have to subtract 8 from both sides, and I'll get an h is equal to -8. So the two solutions to the equation is 7 and -8. Okay, let's look at this next problem. Again, we're going to do the same thing. We're going to factor by grouping. We want two numbers that add together to get -1 for our middle term. And then multiply, instead of multiplying together to get -3, we want two numbers that multiply together to get -6. And the reason why we put a -6 there is because of the 2 that's right here. Anytime you have a leading coefficient other than 1, you need to take that leading coefficient, multiply by your last term. And so 2 times -3 gives you -6. All right. So our options here, again, because I have a negative, one of my terms needs to be negative. And because my middle term is negative as well, then my bigger value needs to be negative. And so I can do 1 times -6 will give me -6, or I can do 2 times -3 will also give me -6. But I'm going to use the 2 times -3 because 2 minus 3 gives me a -1. So this is the correct pairing that I want to use. And so I'm going to set my factors up. There are all my terms, my 4 terms. Those are my 4 terms. And then I'm going to group them. What can I factor out of both of those? Well, I can factor out a 2x from both of those. And what I have left in the parentheses is the x plus 2. And from both of these terms, I can factor out a -3. And I'll have an x plus 1. I think I said x plus 2 earlier. Sorry about that, guys. It should be an x plus 1. Anyway, now both this term here and this term here have the x plus 1, so that can be factored out. We just have an x plus 1, and then what we have left would be a 2x minus 3, and that is set equal to 0. Now to finish finding the solutions, I'm going to set both of my factors equal to 0. Sorry, I had to get a drink. All right, so we set the first factor equal to 0. The x plus 1 is equal to 0. We end up solving for x, and we get x is equal to -1. And then when we set the second factor equal to 0, the 2x minus 3, we do need to go ahead and do the steps to solving this. So we will add 3 to both sides. And then once we do that, we'll be left with 2x is equal to 3. And then we divide both sides by 2. And we'll get x is equal to 3 over 2. Next set of problems, we are simplifying expressions. Okay, so we have a whole bunch of exponential properties here. When we have the same base number, we are going to add up all of our exponents. So here we would have m raised to the 4 minus 5 plus 7 power. And 4 minus 5 plus 7 is 6. So we'll end up with m to the 6th power here. Over here, we have to simplify what's in the parentheses first before we take care of what's outside of the parentheses. So we're going to do the 4 divided by 2, and that will just give us a 2. And then when we are dividing like this, then we are going to subtract, and we have the same bases, we are going to subtract the variables. So it'd be x raised to the 4 minus 1 power, or excuse me, 4 minus 3 power, and then raised to the 3rd power. So that raised to the 3rd power, we're not going to do anything with that until the very end. So now we have 4 minus 3 just gives us a 1. So we'll end up with just 2x, or x to the 1 power in the parentheses. And now we're ready to distribute this raised to the 3rd power out here. And so we'll have 2 to the 3rd power times 3 to the 1 times 3, because my exponent is 1 here. And when I have an exponent raised to another exponent, I multiply those two exponents together. And so we have 2 to the 3rd power is 8. And 3 to the 1 times, or excuse me, x raised to the 1 times 3 power is just 3. All right, same thing for c. You have to simplify what's in parentheses first. And so in the parentheses, we're going to have, because these two are being multiplied, we'll add them together. So b raised to the 5 minus 2 power, because it's a negative. And then this 3 down here, because we're dividing by b to the 3rd power, we're also going to subtract by 3. And then that's raised to the -5 power. Okay, so 5 minus 2 minus 3 is just 0. So we're just going to have b to the 0 power raised to the -5 power. Well, you're multiplying this situation because you have an exponent raised to the power of another exponent. You're going to multiply, and we end up with b to the 0 power times 5. And 0 times 5 is just 0. So we'll have b to the 0 power. And anything raised to the 0 power is always going to equal 1 here. All right, the last one. This one is, we have variables with exponents, but this time we're just adding polynomials. And this one, they like to confuse you by adding these extra set of parentheses. You don't need them because you're adding. Anytime you add, you don't change your signs anywhere. So with this, you just really need to combine like terms. And if you'll remember, like terms have the same variable and the same exponent. So this a squared here, the 7a squared, and this 9a squared, those are like terms because they both have the variable a and the squared. And then this negative 3a is like terms with the positive 11a. Notice that it doesn't matter what your number is, the coefficients. We don't care about the coefficients. In order to be a like term, you have to have the same variable and the same exponent. And then this positive 14 here, that's just going to be left on its own at the very end. So we end up with 9 times a squared plus, because we're adding, 7 times a squared. So in this case, you're just going to add the coefficients. You never add the exponents when you're adding terms. We're adding the coefficients. So 7 plus 9 gives us 16a squared. And then the negative 3 plus 11a is going to be positive 8a. And then the positive 14 at the end is just going to stay there. Okay. All right, this one, simplifying the expression. Let me get rid of those. Okay. Again, we can either FOIL or box anytime we have a situation where we have binomials, or in this case, a trinomial multiplied by a binomial. But boxing helps tremendously with this. And that's because we can go ahead, we don't have to have a square 2 by 2, we can do a 3 by 2. So because I have 3 different terms here and just 2 terms here, I'm going to have a rectangle that has 3 sides times 2 sides. Okay? And again, you just multiply the column and the rows together. And so I'm just going to uncover these. This is the values that we get when we multiply our rows and our columns together. The biggest thing, check your signs and your exponents. So notice the x squared here times x gives you x cubed. You add the exponents when you're multiplying variables that are the same. And then x times 3x gives you 3x squared. Negative 4 times x squared gives you negative 4x squared. And then 3x times negative 4 gives you negative 12. You know what? I forgot the x there. Sorry. Negative 12x. And then negative 4 times negative 2 gives you positive 8, because a negative times a negative equals a positive. Okay, and then again, like we did earlier when we boxed, we can do these diagonal lines, and that just helps separate your like terms. So x to the 3rd power is kind of on its own. It's going to be at the very front. And then the negative 4x squared plus 3x squared is just going to give you a negative x squared. And then negative 12x minus 2x gives you negative 14x. And positive 8 at the end, because we can't. I forgot this line over here. This positive 8 is saved at the very end. It's all by itself. All right, moving on. All right, how many solutions are there to each system of equations graph below? So this time they've already given us the graph of our system, and we just need to look at it and state how many solutions. So again, on your graphs, the solutions are your intercepts, or they're where the 2 lines intersect. And so So let's just look at them. We can see an intersect here and here. I don't need to know the location. I just need to know how many solutions there are. In this case, there are 2 solutions for graph A. For graph B, again, because those lines are right on top of each other, there are infinite many solutions. And for C, we just have one intersect here. And so this one just has a 1 solution. And D, we have another set of parallel lines. And so we have no solutions there. Okay. Next question, we want to solve the equation k divided by 6 minus 8 equals 34. This one is just making sure you are solving in the correct order. So we want to take care of the negative 8 first. So we're going to add 8 to both sides of our equation. And when we do that, we are left with k, hold on, I'm trying to remember how I set this up. There we go. We're left with k over 6 on one side of the equal sign and a 42 on the other side, because 34 plus 8 is equal to 42. And then the easiest thing to do would be to multiply everything by 6 to get rid of this 6 here. And so I need to multiply the k over 6 by 6. The 6 cancel each other out. But I also need to multiply the 42 by 6. You can either plug it into your calculator or calculate it on your paper, and you get 6 times 42 is 252. All right, moving right along. Solve this system of equations. So this time there's a couple different options. I think the best thing to do would be to distribute everything as much as you can. So this 4, multiply both terms by 4 in the parentheses. So 4 times x and 4 times 9. And then here we need to multiply both terms by the 2/3. And so make sure you do that. But one thing nice here is we don't have to worry about the fraction, because this 3 is going to reduce that 9 to a 3. And we're going to reduce the 12 to a 4, because 9 divided by 3 is 3, and 12 divided by 3 is 4. Okay, so when we're doing this, we end up with the 4 times x is 4x, 4 times 9 is plus 36, equal sign, 2 times 3, whoops, oh, I know what I did. I got rid of the 3 down here first. So when we get rid of this 3, or when we distribute the 3, we're just left with 2 times 3x minus 4. We do need to go ahead and distribute that. We get 6x minus 8 when we multiply both of those terms by 2. And now at this point, we can go ahead and put everything with a variable on the left side and everything without a variable, all your constant terms, on the right side. So we're going to subtract 6x from both sides. Oh, sorry. I'm moving the variable to the right and then constant terms to the left. Sorry. So the opposite of subtracting by 8 is adding 8. So I'm doing positive 8 over here. And I am subtracting by 4x on both sides. So 36 plus 8 is 42. And 6x minus 4x is 2x. Now I'm going to divide everything by 2. And 44 divided by 2 is, you know what? 44 divided by 2 is not 11. It is 22. Sorry about that, guys. Let me erase that. Okay. Now evaluate x squared plus 2y minus 9 if x is equal to 6 and y is equal to negative 2. So all we're doing is plugging in a 6 for this x here and a negative 1 for the 2. And that's really all you have to do. So we get the equation is going to end up being 6 squared plus 2 times negative 1 minus 9. Then we can go ahead and simplify this. So 6 squared is 36. 2 times -1 is -2. And then we have a minus 9. Well, 36 minus 2 minus 9 gives us 25. This one, we are using the quadratic formula to solve the following two problems. We have this equation, and we want to solve them. For your reference, I am going to include the quadratic formula on the test. I'll have it just on a little window up here, all by its lonesome. And you will be required to figure out what your A value is, your B value, and your C value. So again, hopefully you remember that A is the variable, or excuse me, the number in front of your x squared term. B is the variable in front of the x term, and C is your constant term. So in this case, when I set up the equation, I'll have a -6, or I'll start off with -6 in the numerator, and then the plus or minus the square root of 6 squared minus 4, and the -4 is just in your equation, times your A value, which is -3, times your B value, which is 1, and then in the denominator we have 2 times -3, because our equation has 2 times your A value in the denominator. So at this point, you need to simplify it as much as you can. The 2 times -3 just becomes a -6 in the denominator, so I'm going to uncover that. And the -6, just leave it on its own, plus or minus. The 6 squared is going to be 36, and then -4 times -3 times 1 gives you a positive 12. Okay. And then we'll end up with, in the numerator, -6 plus or minus 48, because 36 plus 12 equals 48. And so I need to figure out what the square root of 48 is. And unfortunately, it's not a perfect square. So I'm going to do my little factor tree. For 48, the square root of 48, I can do 4 times 12. And 12, I can factor by 4 times 3. So now I have the square root of 4 times the square root of 4 times the square root of 3, and that's going to equal the square root of 48. And because I have 2 square roots of 4, I can simplify that to 4, because I'm bringing out the 4 here because it had a set under the radical, times the square root of 3. So the square root of 3 is stuck behind. Okay? So go ahead and set up your, I need to set up the numerator. We're going to change the square root of 48 to 4 times square root of 3, because we can reduce it. If you can't reduce your radical, you need to. Go ahead and reduce it. And then notice here, every single one of our numbers, whole numbers, not the radical, we're going to leave the radical alone. If I can't pull it out of the radical, that's going to stay by itself. We're not doing anything with that. But all the other numbers are even numbers, and so I can divide everything by 2. And notice that I have a negative sign here and here. Those negatives cancel out. So I'm just going to make them positive. And so I can divide this 6 by 2, and that'll give me a 3. And I can divide this 6 by 2, and that will give me a 3. And I can divide this 4 by 2. And so once I reduce my fraction, I end up with 3 plus or minus 2 times the square root of 3 divided by 3. Okay, these two problems are not going to be nice and pretty. They're not just going to be a whole number. That's why we are using the quadratic formulas, because it's not just a simple whole number. Alrighty, moving on. Sorry, let me get rid of that arrow. There we go. Let me see, this is the second problem we are using the quadratic formula for. So this time my B value is 12, my A value is positive 2, and my C value is 21. So I'm going to set up the equation like I should. Negative 12, there's 12 squared here. Negative 4 times 2 times 21. And then in the denominator, 2 times 2 because of the A value there. So now I need to go ahead and just simplify everything that I can. In the denominator, again, 2 times 2 is 4. So my denominator, I just have 4. The negative 12 that's out front is just going to stay negative 12 for a while. But the 12 squared becomes 144. And then the negative 4 times 2 times 21 gives me a negative 168. And negative 144 minus 168 gives me a negative 24. And again, I need to simplify what's under my radical. So this square root of negative 24, I can factor it as I times square root of 4 times the square root of 6. And this I is from this negative sign. Remember, your I value is just equal to the square root of negative 1. So anytime you have a negative number under the radical, you can pull out that negative sign by just putting the I in front of your radical. Okay, and then the factors of 24 are 4 and 6, and the square root of 4 is 2. So this simplifies further to 2I times root 6. Okay, so now let's go ahead and plug that into our fraction. So negative 12 plus or minus 2I times root 6 divided by 4. And now I can simplify further because the 12, the 2, and the 4 are all divisible by 2. So I'm just going to reduce my fraction by dividing all those numbers by 2. Notice my root 6, the 6 is also divisible by 2, but I'm not doing anything to the root 6. I'm leaving that one completely on its own. I'm just dividing all my whole numbers by 2. And then this 2 times I divided by 2, we're just left with an I here. Yep, I think we're ready to move on to the next one. So we've got this graph, and this graph represents how much it costs to rent a bike. Which of the following are true statements? So according to this graph, we have the cost on the y-axis and hours rented on the x-axis. And so these are showing how much it costs to rent a bike per hour. So let's go ahead and look at this. So the rental is $5 per hour. That is false. And the reason why is because of the number 5 here. So this dot is at 5, but this on the y-axis, we are at 0 hours, right? You are. All right, so that's a 0 hour. We haven't even rented the bike. But what this indicates is that it's not $5 per hour. It's like a $5 deposit that you have to pay no matter how long you rent the bike for. So the bike rental is actually only $2 per hour. And the reason why we know that is because the difference in cost, so this part would be $7 and this part would be $9. And the distance or the difference here on the x value is just 1 hour. So notice it only increases by $2 for each hour that you're renting the bike for. Okay, so that one's wrong. It's not $5 per hour, it's just $2 per hour. And then this next statement, the bike was rented for 5 hours. We have no idea how many hours the bike was rented for. This is just showing you how much it would cost according to how many hours you're renting it. So the statement is also false. And then the next one, the deposit for the bike is $5. That one is true. And then the y-intercept represents nothing. Well, that's false because we already talked about how this y-intercept represents the 0 hour and that it indicates how much it costs to start the rental. No matter how many hours you rent this bike for, you have to first pay $5 deposit. All right, so this one, part C, is the only true statement. All right, moving on. Write the equation in slope-intercept form of the line passing through these 2 points, -2, 0, and 6, 4. All right, so slope-intercept form for a line is y equals mx plus b, where m is the slope and b is the y-intercept. And in order to find your slope, you have to do y2 minus y1 divided by x2 minus x1. And so we just need to plug in our x values and our y values. So here's an x value, here's another x value, here's a y value, and here's another y value. It doesn't matter which one is 0.1 and which one is 0.2, but in this case, I have labeled this point as x1 and y1 and this point as x2 and y2. So when I plug everything into the equation, it looks like this. We have 4 minus 0 divided by 6 minus -2. We do want to go ahead and simplify that. So we have 4 in the numerator and 6 minus a -2 just becomes 6 plus 2. And then that will give us 4 divided by 8, and that fraction can be reduced to 1/4. So now I know that my slope is 1/4. I can go ahead and plug that into my equation, and this time I need to find my y-intercept. And to do that, I'm going to use one of my sets of coordinates here, and I'm going to plug it in to my equation so I can solve for my b value. So we have 2 sets of coordinate points we can plug into this equation, and it really doesn't matter which set I use. I just randomly picked 6 and 4. The biggest thing to remember is that your y value is going to be 4 and your x value is going to be 6. So I plug that in. So y is 4, 6 is my x value, so 1/4 times 6 plus b is going to equal 4. And I want to go ahead and simplify this, so I get 6 over 4. Well, that 6 over 4 can be reduced, so I now have 4 is equal to 3 over 2, and then I want to subtract 3 over 2 from both sides, so I can get b by itself, and I'll end up with 4 minus 3 over 2. But notice here my 4 became 8 over 2, and the reason why is I have to have a common denominator before I can add or subtract fractions. And so this 4 is going to be multiplied by 2 over 2, so I get 4 times 2 is 8 over 2, and then 8 minus, and that's going to give my b value, and 8 minus 3 is 5 over 2, and so my equation is going to be y equals 1/4, which was my slope that I found up here, times x plus my b value, which is 5 over 2 right here. All right, next set, I have a function -t squared plus 4t plus 21 models the approximate height of an object t seconds after it is launched. How many seconds does it take the object to hit the ground? So there's a couple different options I have to do this. The first option is just to graph this equation, but one thing to know, when you graph the equation, don't use t in your calculator. Okay, so let me show you what happens when you graph the equation and you try to use a t value. All right, so let's go ahead and graph this. So if you do, make sure you do the -t squared plus 4t plus 21, it'll ask you to create a slider. You don't want to create a slider for that. So what you're going to do is, instead of using the t value, you're going to use x. Okay, just replace your t with x, and you can graph it. And you get this shape where you have this intersection right here and you have an intersection right here. Okay, so if I graph this, and the question asks, how many seconds does it take the object to hit the ground? Well, in this case, my x-axis represents the ground, because what this graph is showing is the height of an object. And notice that way over here we have two intersections. We have one intersection, x-intercept, at -3 and one at +7. But we don't care about this one, and the reason why is because this equation, we only care about the equation after an object is launched, and it's going to be launched when t is 0. So it starts off way up here. Somebody throws something, maybe they're standing on a building or something, who knows. They throw something out, and then it goes up and it gets the maximum, and then it's going to start falling, and then it hits the x-axis or the ground when your x value is 7. And in this case, the x-axis represents your time in seconds. Okay, so the y-axis represents the height, and the x-axis represents the time. So in this case, it would take 7 seconds to hit the ground. Now, if you forget this, you can go ahead and factor by grouping like we've done before. A couple things to note is that it's really difficult to work with a negative in front. So you can factor that out by changing the signs of each of your terms. So what I did here is I factored out this negative, and I changed this plus 4t to a minus, and then the plus 21 to a minus as well. Then I have to divide everything by -1, and you can totally do that, and 0 divided by -1 is just 0. So all that happens is I get rid of the negative sign, and these signs change. Okay, now I need two numbers that multiply together to get -21 and add together to get -4. So that tells me that one of my numbers is going to be a negative and one's going to be a positive, and my bigger number is negative because this sign is negative up here. So really the only option I have is a +3 times t and a -7 times t. And so when I do that, I get my groups, I can factor them out, I get those factors, I set both factors equal to 0, I solve for my t value, and I get t is equal to -3 and 7. Notice all this work, and I could have just graphed it and it gave me the exact same result. The biggest thing to know is we don't care about the negative value. Okay, that's just an extraneous answer, because that's like before the person launched whatever it launched. Okay, so we only care about this 7 here. All right, next scenario, next problem. What are the solutions to the equation? Again, now I went ahead and changed my a variable to x's just because you'll see in a minute. I don't want you confusing a's, because I think we do end up having to use the quadratic formula for this. All right, so the biggest thing to remember is you can't leave this 17 over here. You want to move it over. So we're going to subtract 17 from both sides, and now our equation is x squared plus 4x minus 17. And we would factor by grouping, so we want two numbers to add together to get 4 and multiply together to get -17. And this would require one to be negative and one positive. And 17 is a prime, not a prime number. Yes, it's a prime number. The only two terms that multiply together to get 17 are -1 or 1 and 17. Well, -1 plus 17 does not give us 4, so we are going to have to use your quadratic formula here again. And so the reason why I changed my a here to x's is because I did not want you to get those confused with your a's in the quadratic formula. Now in this case, my a value is 1 because I have no coefficient there. B is 4 and C is -17. I'm going to plug everything in. All right, when we simplify everything under the radical, we get 4 squared is 16 plus 68. The -4 times 1 times -17 is positive 68. And then the 2 times 1 is just 2 in the denominator. We do need to go ahead and simplify the radical some more, and we get 16 plus 68 gives us an 84. And we need to simplify the square root of 84. So square root of 84 is equal to the square root of 4 times the square root of 21. 21 can be reduced. We can do the square root of 3 times the square root of 7. However, square root of 3 and square root of 7 cannot factor out anything from that. So we're just going to leave this as the square root of 4 times the square root of 21. Biggest thing to note is the square root of 4 is just 2. So we can change this to be -4 times or plus or minus 2 times the square root of 21 divided by 2. And all my whole numbers are divisible by 2. So -4 divided by 2 is 2. And then 2 divided by 2 is 1. So I'm left with -2 plus or minus the square root of 21. All right, moving on. Write the equation of a line passing through the point 2 and -7 with a slope of 1/4. So this is very similar to one of the other problems we've already seen, but in this case they give us our slope, and so we just need to find our y-intercept form, and they give us a point, so we're going to plug in the 2 and the -7 to our equation and solve for our b value. And notice 1/4 times 2 is just 1/2. And then go ahead and subtract 1/2 from both sides of our equation. And we get, again, we need to get a common denominator. So this -7 is going to become -14 over 2. Minus 1/2 gives us -15 over 2 for our y-intercept. So our equation is going to be 1/4 x, or y equals 1/4 x minus 14 over 2. All right, next problem. We are getting close to the end. What are the roots of the equation that is graphed at the right? Guys, just look at your x-intercepts, okay? And this one is at +2. This one's at 1, 2, 3, 4, -4. So my two solutions are -4 and +2. That's all you have to do. Now we are subtracting polynomials from each other. With this one, you really need to remember that you've got to distribute this negative sign throughout each of the terms in the second set of parentheses, and then you can get rid of all of your parentheses. Okay, so the first set of parentheses, just ignore those. You're just going to write everything exactly the way you see it, but without the parentheses. But then the next one, instead of having a positive 7b cubed, it's going to be a negative 7b cubed. Instead of a positive plus 3b, it's going to be minus 3b. And now we want to combine like terms. So positive b to the third power minus 7b to the third power gives us a negative 6b to the third power. Notice, remember, if you don't have a coefficient, the coefficient is 1. And when you're combining like terms, you're just adding or subtracting the coefficients, the numbers in front of your variables. And then we don't have any other b squared terms, so we're just going to write the minus 3b squared. And then the positive 5b minus 3b gives us a positive 2b, and then minus 4, our constant term that was here. We have another situation where we are multiplying a binomial. So we have x minus 2 squared. So x minus 2 squared is the same thing as x minus 2 times x minus 2. And we can either FOIL it or box it. And for the interest of time, I'm just showing you how we set it up by boxing it. And when you combine like terms, notice the two middle terms do not cancel out this time, and it's because they both have the same sign. So negative 2x plus negative 2x is a negative 4x. And if you had FOILed this, you would have gotten the same results no matter which method you use. All right, this one we're solving this equation. The biggest thing to remember is the order of operations. You want to take care of what's in the parentheses first, and inside the parentheses we have an exponent. So we want to take care of that exponent first. So the 5 squared is just going to be 25. And then normally we would divide first, but because we have this 25 minus 1 in the numerator and then divided by 4 in the denominator, it's almost like you have an extra set of parentheses here and here. So you have to go ahead and subtract the 1 from the 25 first, and then 24 divided by 4 is just going to give you a 6. And now we can multiply the 2 by 6 and it gives you 12, and then add the 3 to that, which gives you a 15. Next problem, what is 27% of 90? So for this we need to convert the 27% into a decimal, so it's just going to be 0.27. And in order to find out what 27% of 90 is, we're going to multiply 90 by 0.27, and then we plug that into the calculator or do it by hand, and we get 24.3. Here's some more simplifying with exponential properties. Remember that when you have a power raised to another power, you're multiplying. So in our numerator, that would become 5 times 3 becomes 15. So we'd have 14 raised to the 15th power. And now we can go ahead and subtract the 9 from the 15, and this would simplify to 14 raised to the 6th power. Okay. Could you plug this 14 to the 6th power in the calculator and get an answer? Yes, you could, but I don't need an answer. I just needed to simplify the expression. Okay, I guess we'll do B first. All we're doing here is subtracting the 4 minus 2 in the exponents, and you're left with 14 squared. Here you need to take care of what's in parentheses first, then take care of this exponent. So in the parentheses, we are doing 11 minus 5 because we're dividing here. Anytime you divide the same term with different exponents, you're subtracting the exponents. It doesn't matter if your exponents are the same number or different numbers. You just have to subtract whatever's in the denominator is subtracted from, the numerator's exponent. And so that gives us 14 to the 6th power raised to the 3rd power. Then the 6 times 3, we're multiplying those. And then we get 14 to the 18th power. And then for D, again, D and B are very similar. We're just subtracting our exponents, and we get 14 to the 10th power. All right, next set of problems. We are organizing the following expressions to show the steps in the solution process. Okay, so here's step 1. I need to figure out which of these is step 2 and step 3 and step 4. So from step 1, I need to go ahead and distribute this negative 9 through the parentheses. So it looks like that's what they did here. So this would go under step 2. And then once I do that, I can combine like terms. So this 10x minus 9x will combine. That looks like what they did here. So this would be the 3rd step. And then the 4th step is just getting your answer right there. And then this one, solve this equation. I just want to solve for t. So the biggest thing is eventually I want to get all my t's on one side of the equation and all my constant terms on the other side. So first I want to go ahead and distribute the 2 throughout this set of parentheses, and it's not just a 2, but it's a negative 2 because I have a minus sign in front. So the 4t is just going to be left alone, and then negative 2 times t is negative 2t, and then negative 2 times negative 2 is going to be a positive 4, and then on the other side I'm just left with t plus 4. Now I can combine like terms on the left side, so 4t minus 2t gives me just 2t plus 4, and then t plus 4 on the other side. Now I want to move my t over, so I'm subtracting. I want this t to be over here, so I'm subtracting t from both sides. I also want to take this 4 and move it over, so I'm subtracting 4 from both sides. 2t minus t is just t, and then over here on the right side of my equation, I have 4 minus 4. That gives me 0. So in this case, my t is equal to 0. All right, this next one, I have a graph that looks like this. I want to write an equation in standard form that could match the graph. Well, in this case, I have an x-intercept at -1 and an x-intercept at +2. So the solutions would be x is equal to -1 and +2. But when I plug that in as factors, I'm going to change. I said x was equal to -1 and +2. Notice that I've changed this to x plus 1 from -1 and x minus 2 from +2. So if you have solutions that are negative, the factors would be positive. Okay? But I want the standard form. This is our factored form, so I need to go ahead and FOIL or box that. In this case, I just FOILed it. And now I need to combine like terms, so my two middle terms simplify, and that would be my final equation. Next problem, your science class is going on a field trip to an observatory. The cost is $58 for the bus, plus $4 per student for the admission. Write an equation that gives the total cost as a function of the number of people in the class. So because they use the word "the" right here, that indicates that we're only going to get one bus. Okay, so I want the total cost as a function of the number of people, P, in the class. So for the variables I'm going to use are C and P. So it's going to be C of P, so total cost according to how many people are going. And the equation will be the cost of the bus. Okay, so the plus $58 plus $4 per student, so that's going to be the number of people going is my p-value, so it's going to be 4 times p. Okay, what is the vertex of the equation, of this equation? To find the vertex, I first need to know where the axis of symmetry is, and the formula to find the axis of symmetry is your x is going to equal negative b divided by 2a. So I need to find my axis of symmetry. I need to know what my x value is. So my b value is -6. So I'm going to plug in -6 into my equation, and my a value is 1. So I'm going to have the equation set up like this. Well, I have a -6, which becomes a +6. And then 6 divided by 2 is 3. So my axis of symmetry is when x is equal to 3. Now to find the vertex, I know that the x coordinate is going to be 3. Now I need to know what is my y value when x is 3. So I'm going to take this 3 and plug it into this equation up here. So my y is going to equal 3 squared minus 6 times 3 plus 12. 3 squared is 9. 6 times 3 is 18. So I have 9 minus 18 plus 12. Multiply that all together, and I get a 3 for the y value as well. So now my vertex is going to be at the coordinates of 3, 3. Next problem, write an equation for the slope in slope-intercept form of the given line. So for this slope-intercept form is y equals mx plus b. My b value is my y-intercept, and I can clearly see my y-intercept is at -1 here. So my equation will have a -1 at the end. And now I just have to find my slope. So if I start here and go to the next point up here, or go to the right, I'm going to have to go up 1. So my rise of my slope is going to be 1. So in the numerator of the slope, it's going to have a 1. And then now I just have to figure out what's in the denominator. So I'm going up 1. I have to go to the right 4. So 1, 2, 3, 4 to get to my next coordinate or dotted point or dot on my line. So I'm going up 1 over 4. So in my denominator, I would have a 4. All right, if f of x is equal to 2x minus 3, find f of 4. So in this case, notice your x's here and here. We're replacing those x's with 4's. So to find f of 4, I'm going to put a 4 in for x. So 2 times 4 minus 3. 2 times 4 is 8 minus 3 gives you 5. What is the name of each of the following graphs? Well, this one we're very familiar with. It is our linear graph. And this one, we've been looking at it quite a bit. You can either say it's quadratic or a parabola. Both of those terms will apply. This one you guys may not be super familiar with. It is the exponential graph or exponential function. And this graph here, when you have this v, is an absolute value. You guys have seen that before as well. Next one, create an equation for a line that is parallel to this equation. Well, parallel lines have the same slope. So right here, this 4, my equation, whatever equation I come up with, is going to have the exact same slope. So it needs to have the y equals 4 times x. And the y-intercept doesn't matter. It can be a negative or a positive. It can even have the same y-intercept sometimes. It will, not very often, but sometimes. As long as it has the same slope, then we have parallel lines. Actually, for parallel lines, you should not have the same y-intercept unless they're right on top of each other. All right. So the next question is create an equation of a line that is perpendicular. So for parallel lines, you have the same slope. For perpendicular lines, you have a reciprocal slope or opposite reciprocal sometimes. And so what you'll need to do is, again, your y-intercepts, we don't care about the y-intercept. We only care about the reciprocal slopes. So anytime you have a whole number, you have an imaginary 1 or a hidden 1 is in the denominator. So for the reciprocal, it just means to flip your fraction. So instead of a 4 over 1, we're going to have a 1 over 4. And your slope has to be opposite reciprocal. So because this is a positive 4, we're going to have a negative, and it's a whole number 4, so this becomes a 1 over 4 instead of 4 over 1. Okay, again, we don't care about the y-intercept. It can be a 2, a -2, a 3, a 5 million, doesn't matter as long as the slope is opposite reciprocal. This one, write the equation of the inequalities shown. So before I start going into the equation, I just want to show you all 4 of these. If you notice, every single one of these lines is exactly in the same position. You have the same y-intercept, the same x-intercept. Some lines are dotted, some lines are solid. And then for the inequality part, sometimes the bottom part is shaded in and sometimes the top part is shaded in. So first we need to figure out what the equation of the line is going to be. And we know that our slope, we are going down because when we move from left to right, we're decreasing. And we know that our y-intercept is at +2 here. And we're going down 1 into the right 1. So our slope is just going to be -1. So for this, our equation, this one here, our equation is going to be y, and we're not sure what our inequality is just yet, but the numbers part will have a y, a -1 for the slope, times x plus 2 because our y-intercept is at 2. And because we have all of the same formula, or the same shape on our line, the same slope, the same y-intercept, the numbers are all going to be the same. Now we just have to figure out, is y going to be less than or greater than x? And notice the difference is here. We have the equals line here because our line is solid. We don't have the equal line here because we have a dotted line, and that's how we know whether we use the equal line or not. Okay, so this time I need to plug in a point for x and y and simplify it to see what happens. So if you can pick the point 0, 0, always pick that point. It makes your life so much easier, but you really could pick any point you wanted. So we're here, we're just going to put 0 in for y and 0 in for x, and we'll have 0 is something to -0 plus 2. Okay, well, -0 is just 0, so I'm going to have a 0 and a 2, and in this case 0 is less than 2. So for this graph, we're using the less than symbol because the shaded section is where the 0, 0 is, and so because 0 is less than 2, we're using this graph here. So in our equation, we go ahead and use their x's and y, put our x and y back in there, and we're just going to say y is less than or equal to -x plus 2. Now over here, we can do the same thing with our 0, 0s, but this time, I don't know why I did that. 0 is less than 2, which means I probably messed up over here. I sure did. Okay, so here, whoops, that was right. So here we have 0 is less than 2, which here is our 0, 0, but it's not shaded here. We want it shaded over here. So we know that 0 is less than 2, so the equation would use the greater than symbol here. Okay? So now that we know what our basic formula is, it's going to be the same. And if your graph is shaded where the 0, 0 is, then it's going to be, we're going to use the less than symbol. If it's shaded on the opposite side, we're going to use the greater than symbol. So for the next two, it's super easy, except because it's shaded up here, I'm using the greater than symbol. Because it's a solid line, it's the greater than or equal to. Because it's shaded down here, we're using the less than symbol. We are almost done. All right. So solve this inequality. So we want to get, let's see, let's go ahead and distribute this. Did I distribute or did I divide? I think I just distributed. Yep. I went ahead and distributed. Oh, I remember why I distributed. Okay, so go ahead and distribute this. So 7 times 2x is 14x, and 7 times -3 is -21. And notice you have 14x minus 21 is greater than 14x minus 21. Well, that's not greater than. Those are equal to each other. And so I have no solution here. It's inaccurate. Okay. Next one, I'm simplifying, right, in simplest radical form. So if anything I can pull out from under the radical, I want to go ahead and pull that out. 64 is a perfect square. That gives me 8 times 8 is equal to 64. And x to the 6th power, I could rewrite that as x cubed times x cubed because 3 plus 3 is 6. And notice I have a pair here with the 8, and I also have a pair of x cubes here, so both of those can get pulled out of the radical. And my radical is gone. Now this one, notice I have this 4x out front. It needs to go ahead and stay out there for now. And then the 32, I can do 32 divided by 4 is 8, but 8 divided by 4 is 2. So 32 can be 4 times 4 times 2. And then x squared can be rewritten as x times x. And y to the 5th power, yes, I can write it y times y times y times y times y. But I don't want to. I'm just going to do y squared times y, because 2 plus 1, you would add up all those and you would get a 5 for the exponent. Okay, so now we need to figure out what can come out of the radical and what has to stay behind. So the 4x that is here still has to stay there. And then because I have 2 4's here, I can pull out the 4. And then this 2, I only have 1 of, so that has to stay behind, but I have 2 x's, so I can pull out the x. And I have 2 y squares, so I can pull out a y squared. But what gets left behind is this 2 by itself, and the y that's by itself is going to stay under the radical. And then anything that can be multiplied here, go ahead and multiply together. So 4 times 4 becomes 16, x times x becomes x squared, and then that's what we get. All right, with this one, I want to factor each of the following. So my greatest common factor here, both 21 and 14 are divisible by 7, so I can factor out a 7. And the x squared and the x, I can factor out an x. And what's left is going to be 21x squared divided by 7x will give me 3x. Or excuse me, I forgot that 3. Hold on, let me fix that. 21x squared divided by 7x is 3x. And then negative 14x divided by 7x is a negative 2. For B, I'm going to have to do factoring by grouping. So I want two numbers that multiply together, add together to get negative 4, multiply together to get 32, or negative 32. So I'm going to have a negative 8 and a positive 4. So I can set up my 4 terms, factor out an x from both of these terms. Looks like I can factor out a negative 8 from both of those terms, and this is what I have. Factor out the x plus 4 and x minus 8. And this time I'm just factoring, I don't have to solve it. For C, let me see, factor by grouping again. I want to have a positive 16, and negative 4 times 35 is negative 140. My factors, these are my two factors. I need to figure out which of the, hold on, do either of those give me a 16? Let's see, negative 5 plus 28 give me a positive 23. Negative 7 plus 20 give me a positive 13. So neither of those work, so I will have to use my quadratic formula again. Sorry if you hear my dog barking in the background. Let me go ahead and set up my quadratic formula, plug everything in, simplify, combine. The square root of 816, I can divide by 16, and I get 51. 51 is a prime number. The square root of 16 is 4, so I get that. And each of those terms are divisible by 4. And notice, I don't think I addressed this earlier, but because I have both a negative here and here, those negatives cancel each other out. Next one, and these are the last two problems. So I have 49x squared minus 144. Hopefully you guys are saying, hey, the 49 is a perfect square, so is the 144. So I can rewrite that as 7 squared times x squared minus 12 squared, because 12 squared is 144 and 7 squared is 49. And this is a difference of squares, so you set it up like this, 7x minus 12 times 7x plus 12. Those are my factors. The last one, x squared plus 16. Yes, 16 is a perfect square, but I'm adding here instead of subtracting. So notice up here I was subtracting. This is not a difference of squares because we're adding, so this is not factorable. All right, that is the end. Sorry, I know it's a long video, but the more you watch this and study it, the better you will be prepared for your Algebra 1 final. Good luck. Please watch this and study as much as you can.